Hi, and welcome back to Math with Sophia, a part of Sola Math. Find more math resources at solamath.com. In this video, we'll be going over how to find the distance between 2 points and how to find segment length. So to do this, we're going to need to use the distance formula. So let's get started with some examples. Here we're looking for the distance between these 2 points. To find the distance, we need to use the distance formula, which is d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. So all of that is under the square root. So the first thing we want to do is label our points. So let's label this x1, y1, and x2 and y2. And now that we have it labeled, all that we need to do is plug these into our formula. So we'll get d equals the square root of x1 minus x2 is negative 2 minus 1. So negative 2 minus 1 squared plus y1 minus y2 is negative 4 minus 0. So negative 4 minus 0, can't forget the squared. And now we simplify. D equals the square root of negative 2 minus 1 is negative 3 squared plus negative 4 minus 0 is negative 4 squared. And then we'll simplify that further, and we'll get the square root of negative 3 squared is 9, negative 4 squared is 16. So 9 plus 16, which equals the square root of 25, and the square root of 25 equals 5. So the distance between these 2 points is 5 units. Let's look at another example. So example 2, we're given negative 2, 7 and 4, negative 1. So again, the first thing we want to do is label our points, x1, y1, and x2, y2. And we're going to write our distance formula, which is the square root of x1 minus x2 squared plus y1 minus y2 squared. And now we'll plug our values in. So the distance equals the square root of x1 minus x2 is negative 2 minus 4. Negative 2 minus 4 squared plus y1 minus y2, 7 minus negative 1 squared. 7 minus negative 1 squared. And that becomes the square root of negative 2 minus 4 is negative 6. Don't forget the squared. Plus 7 minus negative 1 is 7 plus 1, so that's 8 squared. So that equals the square root of negative 6 squared is 36. 8 squared is 64. So 36 plus 64, which equals the square root of 36 plus 64 is 100. And the square root of 100 is 10. So our distance is 10 units. Now let's look at example 3. So again, we're given 2 points, 8, 5 and 3, 7. And we need to find the distance. So we're going to use the distance formula again. Let's label our points. x1, y1, and x2, y2. And then we will plug it into our formula. D equals the square root of x1 minus x2 is 8 minus 3 squared plus y1 minus y2 is 5 minus 7 squared. So now we'll simplify that, bring down our square root. 8 minus 3 is 5 squared plus 5 minus 7 is 2 squared. So that equals the square root of 5 squared is 25 plus 2 squared is 4, which equals the square root of 25 plus 4 is 29. So D equals the square root of 29. Now let's try an example where it asks us to find the length of a segment. Here we're given a segment on the coordinate plane. To find the length, we use the same distance formula that we were using to find the distance between 2 points. So we're going to use this same formula. So let's first look at what our points are. We have point S, which is at 1, -3, and point T, which is at 4, 5. So let's label our points x1, y1, and x2, y2. Now we can plug it into our distance formula. D equals the square root of x1 minus x2 will be 1 minus 4 squared plus y1 minus y2 will be -3 minus 5 squared. So now we'll simplify. We get the square root of 1 minus 4 is -3. Bring down our squared. Plus -3 minus 5 is -8. And bring down our squared. That simplifies to the square root of -3 squared is 9 plus -8 squared is 64. So that equals square root of 9 plus 64 is 73. So that is our final answer. The length of segment ST is the square root of 73 units. And if we want to plug that into the calculator, it equals about 8.5. And that is how you find the length of a segment using the distance formula and the distance between 2 points. If you enjoyed this video, hit the like button and subscribe for more.